Okay, welcome. So our team was thinking about what is intelligence, and the idea is that we would like to understand what is sort of an intelligence algorithm at a level where we don't need to use SGD anymore in order to find the algorithm that actually performs well on the task. Like there is some procedure that is like generally good at reasoning about the world, and we want to figure out what is this procedure, what are the multiple procedures that make up this thing, such that we can just write it down all by hand and understand everything. We want to have this kind of algorithm that can be placed in sort of any world, then observes observations about the world, and then at some point is really good at pushing this world into particular states. And the idea of this is sort of that if we were to build such a system, then it would make it easier to see what kinds of properties do we even need in the first place, such that the system is the one that we want, that wouldn't kill us, for example. And it also makes it easier to see that the system actually has these kinds of properties. And ideally this is such that your system is built up the kind of algorithm where you can have lots of intuitions about. I can intuit that some implementation of quicksort will sort the list even without completely mathematically analyzing it. And the core thing that we want to figure out for this is sort of how do we build up models of the world. It seems like that is really a core thing that we want to figure out here. And like I said, we want to ideally have it such that the procedure that builds up the model of the world is we understand how it works and we have good intuitions about it, and ideally we can mathematically prove that certain properties hold. And we also want this data structure, this thing that describes the world, the map of the territory, that this is understandable by us also. And okay, I'm gonna talk now immediately about some sort of concrete details of what we were doing, and after that probably I'm out of time anyway. But basically expect there's a lot more stuff that we're thinking about that I won't just talk about it at all. And maybe you can ask questions about it in the Q&A. I'm just gonna show this stuff then again, and then people can see if something is especially interesting. Okay, so here's the first thing that we were thinking about. It's we have this world model that we want to generate, but how do we do this? What is kind of even the data type of this thing? How do we structure this model of the world? And one idea here is that what we want is we want to sort of factor the world model. What I mean with that is imagine you have some sort of data structure that is your library of objects in the world. So for example, you see a tree, and then you're there is this object called a tree, and it repeats a bunch in the world. That seems like a good thing to save. And that's sort of an important thing in the world. And then you maybe see another tree. And for each of the objects that you see, you want to have this concept and see how here it's already sort of generalized, and that it takes a position, meaning I could sort of think about this tree independent of its position. It's not this particular tree at this particular position, but it's something generalized. And we want to go further with this. Ideally, we want to have sort of some constructor of trees where we don't just take in the position, but also the height or the kind of tree. Maybe we have these kinds of trees, but also really weird trees that still are kind of tree-like, but that are really very different, but still somehow are good described as trees. If you are thinking about, for example, maybe in Minecraft you are thinking about what kind of tool should I use to chop these trees down, and maybe it's for all of them also an axe or something. You can make predictions like that are useful for a wide number of goals. And if we were sort of in the real world, so what we went up with is sort of we have this library, and we have a bunch of these concepts tree, a chair, room, which are all of these constructors that can build things. And what we do with them is sort of imagine we are in one use that you now have, the most obvious use is sort of you're somewhere in the world and you would like to know the surrounding around you. Maybe you're you have some goal, maybe you want to go somewhere or you want to explore, and it's really useful to know that, oh, there's a tree. Now I can run some planning algorithm on this current environment to understand what kinds of action sequences would get me to what sort of states. So that's the first thing, that you want to have like these concepts, and you can like build up sort of like your immediate surroundings, or maybe or like a higher level sort of description that's more coarse about the entire world using these concepts. But that's not the only thing we can do. So like this kind of architecture makes it also really easy for the agent to like imagine things. Like for example, if the agent like knows what, like, oh, this is my house or something, and this is a lava pool, then the agent can like imagine, oh, what happens if I place a lava pool in my house, and it's like, oh, it would burn down my house, that's very bad. Like you can sort of imagine it by like being able to have these components that you can reuse. Or you could imagine something like in survival Minecraft, it would be like really hard to get like enough redstone to like build this computer from scratch. But if you sort of just understand the basics of redstone, like you can just like imagine this computer, that this would be possible. Like at least if you're some sort of computer program that can like memorize all of these things. Like, and that's then like a lot faster. So like imagine like you don't know what kind of computer you want to build, but you want to build some computer in Minecraft. Like trying to build the entire computer and then seeing if it works or if it's good or something what you need, that would be a lot harder than just sort of thinking about it, because now you don't need to actually go into the world, place the blocks, and like gather the resources needed to place the blocks. You can just sort of imagine everything, because you have this like separation. Like basically can simulate reality, or it makes it easier to have this like separation of having the library and the descriptions of the world. Another really important thing for like the interpretability of the system is like we are thinking about some algorithm that automatically infers all of these concepts. Now the thing is though that what you end up with is just like, oh yeah, here's some concept, something. You don't really like, the only thing we know that is some sort of concept because of like, we know here's this library and it contains the concepts. And we probably also know like the type signature, this takes like a vector 2 or something. But we don't know what this is at all, if it was automatically inferred by the system. But what we can do in this architecture is we can sort of like just take an empty environment where there's nothing there, and then we just like place this concept there, and then place also a camera there, and then we like observe it. It's like, oh, look, from this perspective looks like a tree, or from this other perspective look also like a tree. And it's like, oh, and the thing is like, in this environment, you can think about it like a game engine. Sort of you like have this environment and you place this thing down. And if you have like good models about like what's the interaction, for example, between like the trees and like this, like how the agent would model itself, then you could say like, yeah, take this like agent controller, place it also in the environment maybe, or like make some controller that allows me to walk around and interact with the environment, and like just like interact with the environment more, like try to walk into a tree, oh, I can't pass through it, this object is like solid. And so like any sort of like the problem of doing science in this world is like sort of reduced in complexity by it now just being about, I want to have the right computation procedure for investigating sort of this kind of data structure that's in the environment. So like that's really powerful for like investigating what are the individual components that are in the agent's world model, like what do they do. Okay, here's another completely different thing now, very quickly. So we are really interested in finding like the kind of structure in the environment. Seems pretty related to what the previous team was talking about. And here's sort of an example of some structure that we can abstract away to make the environment simpler. So imagine an environment where we are like, we have this arrow and we can be like rotated around in any sort of like every 90-degree angle, and we can move forward. These are sort of the only two actions that you can perform. So if we can do that, then sort of this is sort of like the world state graph. So we can think of a graph where every vertex is like a specific world state, and the arrows are like the edges, like are the transitions that are possible. And so here we would have like this kind of thing where we can like rotate around and then we loop around. So like from this position, if we just think about the rotate action, and we have like a much larger graph, if we think about the rotate action, but also like the position of like that the player can have. And most of the red arrows are omitted, but the red arrows, like they are the things where I like move forward, and like this always would like move like sort of like to the opposite thing. So this is a really messy graph in this very simple world in some sense, that we have lots of overlapping edges. But what we can do now, we can notice like here, look, it's like this kind of pattern that we have like here cell, and here cell, and like we are sort of rotating. Like all of these states are actually slightly different, but there is clearly some really like obvious pattern here. And so what we want to do is like we want to sort of abstract away the rotation of the player, and then we get this kind of graph where sort of we have now only this kind of thing, which is like a really good graph in the sense that now you can actually, well, it's a lattice graph, and now it's really easy to like plan in this lattice graph. We actually have like a post that describes this extremely super trivial algorithm kind of. Basically it's just like here's the thing, compute like the vector and the embedding. It's not exactly clear how you get the embedding, but if you had sort of the embedding of this graph, you just do like vector subtraction to calculate some vector offset that then really easily you can unroll into the actual plan that goes from any position to any other position. So that's how we like transform the graph such that it's actually good. Also thanks to all of these people for working with me.